Welcome back. This is the third video in the series, Getting to Know Cimatron NC. Today I'd like to discuss the following topics: 3-axis finish milling by limit angle, multi-groups for part and check surfaces, automatic boundaries, tangent air extensions, overlap extensions, and fine surface quality. Let's jump right in after roughing. The stock model has been updated with the toolpath. It's still a bit rough, but it's ready for a semi-finish pass. From the left, I'll create a new surface milling procedure, finish mill by limit angle. This procedure allows the user to set a slope angle to separate the vertical areas and the horizontal areas to be machined with different patterns. Any area shallower than the slope angle will be machined with the pattern defined for horizontal areas, and the remainder will be machined with the pattern defined for vertical areas. I'll start by hiding the stock, then carefully select the part faces. And verify automatic boundaries are turned on. Then I'll select a 1/2-inch ball cutter. Next, from the Motion Parameters tab, I'll change the clearance to Optimized. Choose Parallel from a machining pattern on the horizontal areas. It's one of 3 options. The other 2 are spiral in nature. Select Layers for the vertical areas. There are 3 options here as well. Bump flows the cutter up and down the wall, and Helical advances the cutter down and around the detail in a helical motion. Adjust the down step and the side step to 40 thousandths, then the slope limit angle to 35 degrees. And set horizontal cutting mode to mixed. Select horizontal machining expansion and add air extension of a 1/2 inch and calculate the toolpath. I'll take a few minutes to explain some of the choices I made and how they affect the toolpath. The first choice was to use a finish mill by limit angle procedure. On the left-hand end, you can see the result. The vertical walls in the cutout were machined using a Z-layer pattern. The majority of faces are less than 35 degrees and were machined with the parallel pattern at 0 degrees. It can be rotated to any fixed angle by entering an angular value or picking 2 points on the screen. Or an option to set the angle automatically may be used. This is based on local geometry, choosing the shortest or longest dimension to align the tool's parallel motions. Notice by setting the clearance option to optimize, the clearance levels of the pass connections are down close to the part. When I selected the part surfaces, I made sure to turn on automatic boundaries. This option tells the system to stop the cutter at the outer edge of the selected surfaces using the cutter's tangent point. I also used the option for horizontal machining expansion. This creates automatic extensions on the toolpath at the outer edge of the selected faces. It's only offered if the automatic boundaries are used, and it's only available for parallel motions on horizontal regions. Machining expansion may be defined as an air extension or a surface extension, or both. Surface extensions require overlap faces be defined as part surfaces were. I'd like to go ahead and sneak in a re-rough to clear out the slide pocket on the left end, and semi the walls near the flat on the part. I'll hide the curve that illustrates the automatic boundary. I'll create a new volume mill rough spiral procedure. I'll select all of the part surfaces. I'd like to contain the machining with boundaries. Cimatron allows the user to create containment boundaries several different ways. For this part, I'll select groups of surfaces and accept each subgroup to confirm their cumulative outer boundary as containment. Now let's get back on track for finishing. Often a CNC programmer may be required to leave stock on various shutoffs of a part. To simplify this, Cimatron allows the user to designate individual offsets for up to 6 groups of part surfaces and up to 4 groups of check surfaces in a single procedure. Let's copy forward the semi-finish procedure and adjust the geometry. First, I'll set the number of part surface groups to 2. Next, I'll move the surfaces of the louvers to group 2. Adjust the surface offset for group 1 to 0 and the second group to a positive 1.5 thousandths. Adjust the side step and vertical step to 15 thousandths. Save and calculate. The results are tool motions that lift away from the louvers while finishing all of the details selected as group 1 to 0. That brings me to the last 2 items I wanted to discuss today. The first is multi-cutters. It's an option within finish milling and remachine procedures. As I mentioned earlier in the video, by default Cimatron gouge checks the holder to the remaining stock, shifting the tool away to avoid collisions while machining the maximum amount with shorter cutters. For finish procedures, this will result in unmachined areas. For roughing procedures, we simply add a re-rough to eliminate the material left behind by the previous rough. For finish milling procedures, the system is capable of calculating the minimum length for a single specific tool and holder combination. Or if you prefer to work in a more structured manner, it's also capable of automatically swapping in longer cutters where they're required from the tool library. I've opened a slightly deeper part with some procedures already calculated. The first finish procedure has 3/4 inch tools used. By navigating through, we can see how this works. The shorter tool is used to complete the upper area, and the longest does the deepest area. By separating the procedure by tool change, we're able to see the true result. The shortest cutter not only machined the highest detail, but it also machined a large part of the floor detail. Only longer tools were used where the shorter could not reach. And the last option, fine surface quality settings. Cimatron has the ability to control the point distribution of the tool path for finish procedures. This is necessary to achieve the best finishes in some of today's most precise machines. As you can see in the final procedure, I've tightened up the spacing to illustrate this. So rest assured, with this high level of control, users choose the surface quality needed to meet your customer needs. That brings this video to an end. Please stay tuned for the next video, Remachining and Rest Milling.